Welcome to Mathematics Mastery with Bethel, your mathematics teacher. Ready to conquer maths? Let's get started. Welcome to Bethelmatics Academy. If today is your first time on this channel, do well to hit a subscription button below, like the video and share with those that it will be relevant to. So today I'll be taking you through surface area and volume of solid shapes. Before I dive deeper into this topic, you must understand that there is a clear difference between solid shapes and plane shapes. So what are plane shapes? Plane shapes are otherwise known as two-dimensional shapes. They have length, they have width, and they don't have height, no depth, no thickness. Examples of plane shapes include the circles, the rectangles, the square, the trapeziums, the parallelogram, the rhombus, kites, so on and so forth. If you want to be asked a question on the plane shapes, the things you could be asked for includes the perimeter of a plane shape or the area of a plane shape. What are solid shapes? Solid shapes are three-dimensional shapes because solid shapes have length, they have width, and they have height, or they have depth, or they have thickness. So because they have length, have width, and have height, then we can be talking about volumes for solid shapes. So for solid shapes, you could be asked to calculate the area of that shape or the volume of that shape. Solid shapes include the cube, the cuboid, the sphere, the cone, the cylinder, the pyramids, and so on and so forth. So for today's video, I'm going to be taking you through calculations on the cylinder. And in my next video, I'll be taking you through calculations on the pyramid. So let's begin with the cylinder. Number one, the cylinder. What is a cylinder? A cylinder is a prism that has a curved surface, a circular top, and a circular bottom. But I know you're familiar with shapes like the can, the soda can, the tomatoes can, and the rest. So most of those shapes are in the form of a cylinder. Let me make a simple drawing of a cylinder. So this is an example of a cylinder. It has a circular top and a circular bottom. We can be talking about the radius of this circle. We call it R. And then, since this is a solid shape, so this cylinder has a height. And let's call that H. Once we say that this figure is a cylinder, then definitely the size of the circular top is the same thing as the size of the circular bottom. So for the surface area of a cylinder, there are three types of area you could be asked to calculate for a cylinder. Number one is what we call the curved surface area. That is to say, it does not have a cover for the circular top, it does not have a cover for the circular bottom. That means if I put my hand through here, it's possible my hand can come out through here because it does not have a cover. So when a cylinder does not have a cover at the top and bottom, then you could be asked to calculate the area of the curved surface, area of just the body of the cylinder. So the formula for area of the curved surface of the cylinder is given as 2 pi r h. Now the question is why? If I choose to cut this cylinder vertically downward, if I choose to cut this cylinder vertically downward and open it, definitely I'm going to be having a shape that looks like a rectangle, something like this. And if I have a shape that looks like a rectangle, definitely the height of this rectangle remains the same thing as the height of your cylinder. When this now a rectangular shape was a cylinder, remember it was curved like a circle. And what is the formula for the circumference of a circle, the perimeter of a circle? Because it was curved like circle, then the formula for the circumference of that circle is given as 2 pi r. And remember, the formula for area of a rectangle, the formula is given as length times breadth. So what is the length of this rectangle? 2 pi r. And what is the height of this rectangle? H. So treating your cylinder like a rectangle now, in this case our length is now 2 pi r and our breadth is now h. So the area of this surface will be determined by saying this multiplied by this, and that will give us 2 pi r h. Number 2, you could be asked to calculate the total surface area of the cylinder. The total surface area of the cylinder simply means area of the top plus area of the bottom plus area of the curved surface. Of course, what shape is the top? A circle. And what is the formula for area of a circle? Pi r square. So this is pi r square for the top. And what shape is the bottom? A circle. And what is the formula for area of a circle? Pi r square. So we can say plus pi r square for the bottom, and then for the curved surface. And what is the area of the curved surface? 2 pi r h. So this is plus 2 pi r h. So we are going to be doing simplification of simple algebraic expression here. Remember that am plus am will give us 2am. Same way, pi r square plus pi r square will give us 2 pi r square plus 2 pi r h. So this is equal to what is common between, we want to factorize what is common. 2 is here, 2 is here, I'll bring it out. Pi is here, I'll bring it out. R square means r times r. So it means there are 2 r here. So there is r here, there's r here. I'll bring out 1 r here. Open bracket. Remember there are 2 r's here. So what remains here is r plus what remains here is what? H. So the formula for the total surface area of a cylinder is given as 2 pi r bracket r plus h. Now the third one is the total surface area of the cylinder with one open end. So when that is the case, the formula becomes, we are going to have it to be area of the bottom, which is pi r square plus area of the curved surface. Because the top is open, we are not going to add the area of the top. So area of the bottom plus area of the curved surface. And the area of the curved surface is given as what? 2 pi r h. So this is equal to, let's factorize what is common. Simple algebraic evaluation here. So what is common? Pi is here, I factor out pi. R, I have an arrow here, there are 2 r's here, and there is 1 here. So I bring out 1 r, open a bracket, what remains here? R, plus what remains? 2h. So the formula for total surface area of the cylinder with one open end, when one end is open, is given as pi r bracket r 2h. The fourth thing you could be asked here is to determine the volume of the cylinder. Volume for prisms in general, their volumes are given as base area times height. Base area times height. So a cylinder is a prism. So because a cylinder is a prism, it has a base, it has a height. And what shape is the base? Circle. And what is the formula for area of a circle? Pi r square. Then we are going to multiply that by the height, which is h. So the volume is given as pi r square h. So these are the 4 formulas you need to solve problems around a cylinder. You could be asked to determine the curved surface area of the cylinder, which is what? 2 pi r h. You must know this formula if you want to do well in calculations under cylinders. And number 2, you could be asked to calculate the total surface area of cylinder. So when asked to calculate the total surface area of your cylinder, that means the calculation should include area of the top, area of the bottom, and area of the curved surface. So in such a case, use the formula 2 pi r bracket r plus h. You could also be asked to calculate the total surface area of the cylinder with one open end, or when one end is open. That is to say, either the top is open and the bottom is closed, or the bottom is open and the top is closed. In such a case, the area of the one of the circular shape will be missing. So with this formula, pi r bracket r plus 2h. And then lastly, you could be asked to determine the volume of your cylinder, and the formula is pi r square h. So we're going to be taking examples to illustrate how to apply these formulas in making calculations on your cylinder. This is a very good example to illustrate how to apply the formulas you have just learned about. Now, under cylinders, don't expect them to always tell you the terms, the words you know, how you have already known these formulas. I know you are familiar with curved surface area, but they will not tell you curved surface area. They will tell you a cylinder open at both ends. So once they say both ends are open, it simply means curved surface area. So that one is talking about a cylinder open at one end. Of course, that one is surface area of cylinder when one end is open. And then A is talking about the total surface area of the cylinder. Total surface area. That's what A is talking about. That means both ends are closed. Okay, so solutions. So the first thing to do is to write down your parameters. What I mean by parameters is they gave us height to be 24. So you said h is equal to 24 centimeter. They also gave us the radius to be 10 centimeters. So you said, comma, radius is equal to 10 centimeter. Pi, we are giving pi to be 3.14. So let's now go and solve the first question. A closed cylinder. When a cylinder is closed, it means the bottom is there, the top is there, and then plus the curved surface. It's something as total surface area of your cylinder. So the formula is giving us 2 pi r bracket r plus h. So this is equal to, let's substitute the values accurately. 2 times pi is what? 3.14 times r is what? 10 centimeter. Then in bracket, r is what? 10 plus h is what? 24. So this is equals to 2 times 3.14 will give us 6.28. And 6.28 times 10 will give us 62.8. Bracket 10 plus 24 will give us what? 34. So 62.28 times 34 is equal to 2135.2. 2135.2 centimeter square. All right, so this is the answer for the total surface area of this figure. Number B, we are asked to calculate a cylinder opened at one end. So if you're asked to calculate a cylinder, the area of a cylinder open at one end. So it's talking about total surface area when one end is open. So this is equal to, remember, it is what? Pi r bracket r plus 2. So let us substitute accordingly. Pi is what? 3.14 times r is what? 10. Open your bracket. R is what? 10 again, plus 2 times h is what? 24. So this is equal to 3.14 times 10 will give us 31.4. Bracket 10 plus 48. So this is equal to 31.4 bracket 10 plus 48, 58. So this is equal to 1821.2 centimeter square. So the next is C, a cylinder opened at both ends. Number C. Okay, so for a cylinder opened at both ends, that means the circular top is not there, the circular bottom is not there. So we are only left with the curved surface. So it is the same thing for curved surface area. So it is giving us 2 pi r h. I hope you remember. So let's now substitute. This is 2 times pi. Our pi is what? 3.14 times r. R is what? 10. Then times h. H is what? 24. So this is it. 2 times 3.14 will give us 6.28. So 6.28 times 10 will give us 62.8. And 62.8 times 24 will give us 1507.2 centimeter square. So this is it for a cylinder, the area of a cylinder opened at both ends. That is just describing the curved surface area. And then number D, we are asked to calculate the volume of the cylinder. So volume of cylinder is giving us, remember, volume of cylinder is giving us pi r square times h. Pi r square times the height. So this is equal to, what is our pi? 3.14 times r. What is our r? 10. But in this case, we have to put the square. So square means 10 times 10. So I put the square times h. What is my h? 24. So this is equal to 3.14 times 10 square means 10 multiplied by 10. That is to say 10 square means 10 times 10. 10 multiplied by itself. Many students make the mistake of saying that 10 square means 10 times 2. It is very wrong. So 10 square means 10 times 10. So 10 times 10 will give us what? 100 times 24. So 3.14 times 100. So because we have 1 and 2 zeros, I'm going to move this point from here 2 times outward. It becomes 314 times 24. So 314 times 24 will give us, if you do the calculations, we are going to get 7536 centimeter cube. Please don't forget, centimeter square are units for areas and centimeter cube are units for volumes. Let's look at example number 2. So this is example number 2. Of course, this figure is a cylinder. We know that this is a cylinder because it has a circular top and a circular bottom of the same size. So the next thing to do is to write down our parameters. From here to here is our diameter. This number 10 describes the diameter of our circle, of the circular top. That means our circular top has a diameter of 10 centimeter. So therefore our radius will be diameter divided by 2, which is 10 divided by 2, which will give us 5 centimeter. The next parameter we need is our height. H is giving us 14 centimeter. And then we are given pi. Our pi is equal to 22/7. We can now proceed to solve the first question. So in the first question, we are asked to calculate the curved surface area of this figure. So the curved surface area of this figure What is the formula for the curved surface area? From the beginning of this video, I showed you that it is equal to 2 pi r h. So let's now substitute appropriately. This is 2 times pi is given as what? 22 over 7 times r is given as what? 5 centimeter times h is given as what? 14 centimeter. So look at this very well. All these are our numerator. This is a multiplication problem. All this number here, 2, 22, 5, and 14 are numerators. And 7 is our denominator. Can anything go? Yes. 7 can cancel 14. And we are going to be left with 2. So in the end, we are left with 2 times 22 times 5 times 2. So this will give us 2 times 22 is 44. 5 times 2 is 10. So 44 times 10 will give us 440 centimeter square. So the curved surface area of this figure is 440 centimeter square. So for B, we are asked to calculate the total surface area. So the total surface area simply means area of the circular top pi r square plus area of the circular bottom pi r square plus area of this curved surface 2 pi r h. If you want, you can decide to implement it one by one. Pi r square, you evaluate that one, plus pi r square, you evaluate that one, plus 2 pi r h, you evaluate that one. Add everything together, you get the same answer. But I have simplified that formula to mean 2 pi r bracket r plus h. So let us substitute appropriately. It becomes 2 times r. Pi is what? 22 over 7 times r is what? 5. Bracket r is what? 5 plus h is what? 14. So this will give us 2 times 22 over 7 times 5 bracket 5 plus 14 will give us what? 19. Alright. When you multiply the numerator by 2 times 22 times 5 times 19, we are going to get 4180 divided by 7. So this will give us 597.14 centimeter square. So this will be the value for the total surface area of our cylinder. Then lastly on this question, we're asked to calculate the volume of this cylinder. Volume, formula for volume of the cylinder, remember, is given as base area times height. So let's apply the formula appropriately. It becomes 22 over 7 for pi times radius is what? 5, then introduce your square, times the height is what? 14. So this is equal to 22 over 7 times 5 square. 5 square is what? 25 times 14. So in this case, 7 go here, 1, 7 go here, 2. So we are left with 22 times 25 times 2. Our answer is going to be 1,100 centimeter cube. So I'm going to be dropping example 3 for your exercise. So I'm going to be dropping the answer in the description box. So do well to solve example 3 and check your answer, confirm your answer with my answer in the description box below. So this is example number 3. You have understood how to solve problems on cylinder. So I want you to make a trial, get us the curved surface area, total surface area when one end is open, and the volume of this very figure. So get that and then confirm your answer, because check your answer with my answer in the description box below. Please, if you have not subscribed to this channel, do well to hit the subscription button, like the video, and share with your friends. Share with those that be needing it. I'm so glad you joined me on this channel. I will see you in my next video. Thank you for watching.